Question number 56. For 1 mole of a diatomic gas, the ratio of heat transfer at constant pressure to work done by the gas is. We should know that if we talk about the heat transfer, we'll take enthalpy here. Change in enthalpy we are taking, and that's divided by the work done by the gas. It means we are just going to find out their ratio. And if we talk about this delta H value, we can find out this delta H, that is equal to Cp delta T, where we are talking about 1 mole, and for n mole I'm taking here n Cp delta T. So we can place this value of enthalpy here, that is n Cp delta T. What is the Cp? Cp is heat capacity at constant pressure. Now W is P delta V, we all know, and let's place here that P delta V can also be written as nR delta T, and the simple formula that you will obtain here for this ratio, that is equal to Cp by R. The value of Cp is 7 by 2R, and what about the final ratio? That would be 7:2. This is the ratio of heat content and the work done. So this is the ratio, and this ratio is clearly given in option 4, and we'll choose it as the correct option. And now let's take question number 57. The equimolar salt solutions having lowest pH is. In this case, we have different salts and we have to take the solution. We have to find out the salt solution with the lowest pH. So first we need to check the salts given here. If we talk about CH3COO Na, this is the salt of a weak acid and a strong base. The weak acid is CH3COOH and the strong base is NaOH. In this case, pH is always more than 7. It means it is a basic salt. The next one, CH3COOK. It is the salt of acetic acid and KOH, potassium hydroxide. It means the CH3COOK is also a basic salt with the pH more than 7. Now, the turn is here for NH4Cl. This NH4Cl is the salt of ammonium hydroxide, NH4OH and HCl, a strong acid and a weak base. It means this is the salt which is acidic salt. And acidic salt always undergoes cationic hydrolysis, you all know that, and this NH4Cl in water will produce H+ ion in the solution. It means the pH of this salt solution is less than 7. Now let's check the last option also, that is NaCN. This is the salt of strong base and weak acid, comparatively weak acid. So in this case, definitely the solution is basic, and this salt is also considered as a basic salt. The pH is more than 7. So only one salt is there with a pH value less than 7. So for this, ammonium chloride we can take here as the correct answer, because that has a salt solution which has the lowest pH. Now after this, let's take next question. Question number 58. Correct expression for Kc for the given reaction is. The reaction is 2Hi. It's getting changed into H2 and I2. And we just need to find out the Kc value in terms of alpha. In the question it is mentioned that you have to find out the expression for Kc in terms of alpha, where alpha is the degree of dissociation. In this case, let's assume that initially we have the concentration that is 2 molar, and let's assume about this H2 also. Initially there was no formation of H2 and I2 further. We're talking about the Kc value, it means we have to consider the equilibrium. At equilibrium, let's assume that alpha of H2 is formed and alpha of this I2 is also formed. In this case, the concentration of this Hi would be 2 minus 2 alpha. Now, what would be the Kc value? Kc is equals to the product of the concentrations of products, alpha square divided by 2 minus 2 alpha square. And it can be written as alpha square upon, let's take 2 as the common, so it becomes 2 square, or 4, 1 minus alpha square. This would be the value. And this value that we have obtained here is given in option 3. And let's choose it as the correct answer for question number 58. The pH of a solution at 25 degrees Celsius that contains 10 raised to the power minus 10 molar hydroxide ion. It means the amount of hydroxide ions is given, that is 10 raised to the power minus 10 molar. And we need to find out the pH value for this. So we should know that pH is equals to negative logarithm of H plus ion concentration, and the pH value plus the pOH value is equal to 40. We should know that. And here this pOH value we can find out with the help of OH minus ion concentration that's given in the question. So this pOH value is equals to negative log of hydroxide ion concentration, and that is equal to negative log of 10 raised to the power minus 10. It means this pOH value is 10 simply, and if pOH value is 10, then definitely pH is equals to 14 minus 10, that is 4. So pH of the given solution at 25 degrees Celsius is 4, and this is given in option 3, and that's why the correct answer is also option 3. Question number 60. Equal weight of oxygen and helium are mixed in a container. The fraction of total pressure exerted by helium gas is, here we need to find out the pressure with the help of Dalton's law of partial pressure. Very well known law. Now with the help of this we'll find out the fraction of the total pressure exerted by helium gas, and this can be represented. We're talking about the Dalton's law. So the pressure of helium would be equal to, that's the total pressure, into the mole fraction of helium gas. This would be the formula that we're just going to use here. In this case, the pressure of the helium we need to find out. So the PHE upon PT is equal to the mole fraction of helium, and in this question it's given that equal weight of oxygen and helium are mixed. It means in the mixture there are only two gases, so let's assume that the moles of helium that we need to find out, and equal weight we are taking, let's assume that X gram of both hydrogen and helium are taken. So X divided by the molar mass of helium, because we need to find out the moles, divided by X by 4 plus X by 32, the molar mass of oxygen. This one. Now let's solve this. This would become X by 4, and this would be 32 here, and 8X plus X, and this would become 8X upon 9X, or simply 8 by 9. This is the ratio of pressure of helium upon the total pressure. So simply this is the fraction of the total pressure exerted by helium gas, and this is given here in option 4, 8 by 9, and I'm choosing it as the correct option. Now after this, question number 61.